time they say this is an arch of a bridge over a highway. It's semi-elliptical, so it's half of an ellipse. It is 60 feet across. I'm not going to write 60 because that's going to confuse me. I'm just going to write that this distance is 30 so that I only have to look at a relevant piece of information. And the highest point is 20 feet above the highway, so this is 20. And put the center at the origin, so they already have it centered at the origin. Write an equation for the ellipse. So anytime that your center is at 0, 0, you should write out the framework for your equation that x squared plus y squared equals 1 for any ellipse. And then you just have to figure out what your a squared and b squared values are. So how far did I walk in the x direction? I walked 30, right? So what's 30 squared? That's what goes under the x, right? Because whatever a squared is, you take the square root and that's your a value. So this would be 900. How far did I walk in the y direction? I walked 20. 20 squared is 400. So that's the equation for this ellipse. Now we're actually going to do something with our equation. So now it says use your equation and determine the height of the ellipse. So they want to know this height of the ellipse when you are 20 feet away from the center stripe. When this is 20, they want you to find this y value, right? This might be important to see the clearance under the tunnel, right? You don't want a huge truck to go under it and catch the top of it. You know how they've done on the covered bridge in Jackson a couple times, right? So you need to know the clearance. This happens to be elliptical, so it's even harder to figure out the clearance. What they do is they kind of pretend that this is a rectangular piece where your car can actually go through. So they don't find the clearance over here. They find the clearance at the edge of the roadway. This is like the shoulder. So we're going to plug in 20 for x, and we'll solve our equation for y. So you can solve an ellipse equation for either x or y if you know one of the two numbers. So we're going to plug in 20. So I would have 400, right, because 20 squared is 400, over 900, plus y squared over 400 equals 1. Are you with me so far? All right, so how can I solve that for y? How can I move things to the other side of the equation? This is just algebra now. What would I subtract to the other side of the equation? Yeah, I'm just going to call this 4/9, right? 400 over 900 is 4/9. So if I'm subtracting 4/9, how many ninths would I have left? Right, so can I write the proportion y squared over 400 equals 5/9? I'm just kind of continuing because I ran out of room. I'm going to do like solving a proportion. Do you remember how to solve a proportion? This times this has to equal this times this when you solve a proportion. You know that from Algebra 1? So, that's cross multiplying, right? So you could write an equation that 400 times 5 has to equal 9 times y squared. Or should I do it a different way? Did you guys not learn how to solve proportions in geometry? What? Sure. Yeah, I'm just going to do 400 times 5 divided by 9. Do you guys know the whale instead? All right. So 400 times 5 equals 9y squared, so I'm going to divide by 9. You should be able to solve a proportion. Use whatever method you want. So what is 400 times 5 divided by 9? 222.22. And I have to take the square root of that to get my y value, right? Because right now I have 222 equals y squared. I'm going to take the square root of both sides. Totally ran out of room. How tall is the tunnel? And does it make sense in our picture? I got 14.9. Would it make sense that this has a height of 14.9? Seems reasonable, right? This had a height of 20. This now has a height of 14.9, and it doesn't look like it goes down by that much, right? So 14.9. Is this in feet? Feet. All right, so then the next part says a truck that is 12.5 feet tall wants to go through the tunnel. One side of the truck is going to be on the center stripe. What's the maximum width of the truck that could fit under this arch? So could the truck be 6 feet wide? Could it be 10 feet wide? We need to know if we have the height of the truck, right? How far over the X value gives me that height of the tunnel. So this time we're going to plug in Y, and we're going to solve the equation the exact same process for X. So we're going to leave it as X squared over 900. But this time we know the height of the truck is 12.5 feet. So I'm going to do 12.5 squared, whatever that is, over 400 equals 1. Can you kind of follow the same steps we just did? If you just want to use your calculator, you don't have to make a nice proportion, right? We're really just subtracting this amount to the other side, multiplying by 900 to the other side, and taking the square root. You see that algebra? Subtract the fraction to the other side, multiply by 900, take the square root. So we want to know the maximum width of this truck that would fit under this tunnel. So you should be typing into your calculator 1 minus this fraction, 12.5 squared over 400, right? Hit equals. Then multiply by 900 to get the 900 to the other side. And then take the square root of what you got. Can I say it without writing it down? You should get, I think, 23.4. Is that what you got? So 23.4, there's no truck that's going to be 23.4 feet wide. Right? That would be a pretty wide load. So a normal box truck would be able to fit under the tunnel. All right, let's do number 2, and then maybe we'll save a couple applications for after the quiz tomorrow or for next week. But we want to get practicing on just kind of the skill part, I think, of ellipses. But this is a good one. This is again, it has a semi-elliptical ceiling. It's the whispering chamber idea. So as long as you stand on the 2 foci of your ellipse, right? The ellipse is really up here. The ellipse is just where their heads are. So they're standing on the floor, but when they speak, no matter what direction the voice goes, it'll bounce off the ceiling and go directly to the other person's ear. So it says the total length of the room is 100. The foci are located 25 feet from the center. How high is the ceiling? They want to know the height of the ceiling, right, from the ground. And it says the vertical walls are 8 feet tall. So at the end, I probably need to add 8 feet because what I solve for right now is only going to give me this part of the ellipse. So let's see, what pieces of information do we have? We know we basically want to solve for B, right? Because this is going to be the minor axis, half of the minor axis. Do we know what A is? It says the length of the room is 100 feet all the way across. So what does A have to be? A is just 50, right? So see how I'm just solving for this little piece of the ellipse, right? So A is 50, B is my unknown, and it tells me what C is. C, the foci are located 25 feet from the center. So if I know A, B, and C, or if I know 2 of the values, can't I solve for the other value? A was 50, so I'm going to take 50 squared. I want B, and I know C. So I'm going to take 50 squared, plug it into this equation, that's A squared. Take 25 squared, plug it in. I want to know what B is. So you're solving that Pythagorean identity for B and adding 8 feet to your answer, because the walls are also 8 feet tall to get there. Don't forget to take the square root to get b by itself. What'd someone get? What'd you get? I got 43.3, and then I'm adding 8. Right, yeah. So did you do 50 squared? You did? So 51.3, is this in feet? Feet is the total height, because that's your V value plus the 8 feet of the room. So I took 50 squared on my calculator, I subtracted 25 squared, and then I took the square root of my answer, and that's how I got 43.3. You with me on that?